Hi, Randy. I'm so excited to have you here. Thank you for joining.
Good to see you. Good to see you. Thank you very much for having me. Yes.
Of course, I'm so excited. You and I met at an industry event through a colleague of ours, Katie Werner. She's a dear friend of mine. And she introduced us, and I was immediately enamored. We had great conversation, and I thought, I just wanted to pick your brain about all the smart things that you're doing in the AI space. And we've had a couple conversations since then, and I learned so much from you. So I'm so excited for you to be here today, and we can kind of chat about your background and all the fun things that you're doing in the space right now. So welcome. I'm so
Thank you.
excited. Yes.
Yeah.
Why don't we get started, and you can tell us a little bit about you and your background. It's so fascinating to me. I'd love for you. You could start at the beginning or wherever you'd like to go.
Oh, well, I guess I'll start at my college years. So I studied math. I was simply good at it. And I thought, I bet I can make money with that.
Mm-hmm.
And but this was important to me. I grew up, somewhat impoverished, and I thought, I need a practical education. And when I was in college at Cal, I started working at a securities firm, and basically I was a quant. That was the way they described me back in the day.
Mm-hmm.
So I really loved doing that, and had a pretty good career in that. And at a certain point, I had to write some software to do the work that I was asked to do, because there was no software then that did this thing. You had to kind of create it on your own.
Okay.
And I realized, wow, that's a nifty thing. Like, you could make a thing once and sell it over and over again. And I thought, this is much, much better than what I'm doing. So that is how I got from finance into technology. But for the most part, all of the work that I've done has been really about the same kind of thing, using some kind of complex math to solve some problems. I've done work in encryption. I've been working in machine learning and analytics, and I'm working now at Cognizer. We do natural language technologies for contract intelligence, and they all have that kind of common part. And I see a lot of the work we're doing with that prism. Yeah.
Yes. So when you started your career as I guess the quant, nickname were you an actual mathematician that then translated your skills into technology? Sort of, how did that career change work?
So in my studies were econometrics, which is basically applied mathematics to business problems.
That is the coolest major I've ever heard.
So like I said, it was pretty easy. Like, I think I can make money using this somehow. And the at the time, and even now, the finance world was moving from a place of creativity where more and more different types of asset classes could be financed. But the more complex and esoteric they were, the more mathematically driven they were. And Makes so options and derivatives and things of this nature, I was working on those at their inception. And this was really the big part of what folks needed help with. This is pretty complicated logic and math to being applied to these financial problems.
Yes.
And that's how I got in. That's how I got into finance. And I really think it's very similar to what, in a way, I'm doing now, because I did this a lot for mergers.
Okay.
And the people would bring me in and try to figure out, what is all this stuff worth? Could we take this giant pile of receivables and finance part of this acquisition? Those were the kinds of questions that they were bringing me in to answer.
Okay.
So all of those, all of that work had something to do with due diligence. So there was a deal. They would bring me in. They would think, hey, what's this stuff worth? And how would you package this up? And how it's the most appealing way to make it sell? And so this was my job.
Mm-hmm.
It was complex, from a mathematical point of view, but the objective was pretty clear. I remember explaining it to my mom, who said, hey, what are you doing exactly? Can you explain it to me? I said, Mom, I'm a baker. So there's a lot of wheat and other things. And now everybody likes a different kind of bread. They like some bagels, or they like a French bread, and they want this or they want that. And I turn all that stuff into the things they want. And they're willing to pay more for it if you give it to them the way they want.
Okay.
And so this is all I was doing, is taking cash flows and reorganizing them into different packages that people would pay more for.
Okay.
And that was the whole idea. How can you get more money from these cash flows? And financial engineering, there's a lot of words for it, but basically that's what I was doing.
So when did sort of machine learning and artificial intelligence come into your consciousness from where you were sitting, repackaging the bread?
in effect. Yeah. So early in, because the work I was doing was writing algorithms, and you can say machine learning in their original form were very algorithmic. Right. And that is to say, following a heuristic, some kind of a rule pattern. And I know you worked at IBM, you're familiar with these concepts. So yes. The original purpose of machine learning was just to automate those complicated mathematical steps, because they're gnarly. Right. And then you could teach those things how to do things on their own and figure out patterns. That's the jump from machine learning to neural networks and more artificial intelligence. That concept that it can discover the patterns. That you don't have to teach it the patterns. That
is the part that I get so excited about, and I could nerd out on forever. The neural networks discussion, when I understood what an artificial neural network was, I was mind blown. Which I forgive the pun, because it is neural networks. But just to backpedal a little bit, and I'll tell you why it was so fascinating to me, is that when I started with IBM, I was working with Watson to look at the supply chain for contracting, and it was very early days. I mean, Watson had already been in the Jeopardy game. But what we were working on for contracting was to look downstream at the vendor and supplier matrix and figure out how we could apply neural networks to the supply chain around weather patterns, around financial implications, around sanctions, around all the things that organizations have to deal with their vendor portfolio, and to then give feedback to that supplier to say, the person that's contracting to say, you might want to choose supplier B because there's a weather event for supplier A, and that's going to impact delivery times, et cetera, et cetera, et cetera. So that's what I was working on when I was at IBM for Watson. And it was fascinating to me, because that's when I really started to understand neural networks. It's just mathematics applied, and then a decision coming back, so that a human can either make the decision or automate that process. And so that's my non-mathematical understanding. I just wondered if sort of how you were working with neural networks and your understanding across the contracts continuums. Anyway, go ahead.
Yeah. It's a fascinating point, and it brings me to a topic. So prior to joining Cognizer, a few years prior, I was doing all kinds of consulting, a lot of which was for venture-backed firms. They would bring me in, and they were technical firms, like doing IoT or doing some kind of network stuff where they wanted to apply machine learning, and also wanted to figure out, how do we take all this nifty tech and make some money from it? Because by then I had gotten pretty good at answering those kind of product market fit questions. And I got hired through a funny series of events by Boeing. And they were trying to do the same thing, Cami, that you were just describing. So they had several different divisions, and they were trying to redesign their supply chain network globally. And so they needed to apply machine learning and neural networks to figure out what the ideal supply chain would look like. But the problem they had was some of that data was confidential. It was classified, in fact. And they were trying to figure out, hey, how do I get this data commingled with all this other commercial data so I can run machine learning against it? And that was a big eye opener. I helped them build a platform that allowed them to commingle their data and analyze it without anybody looking at it, which was a nifty trick. And I
Right.
actually patented that.
That's fascinating.
Yeah, it's a nifty thing. It's another conversation for another day. But the point was that data was highly privileged and it was coming out of contracts. And that supply chain data was so important. But if you didn't get the data to the people who needed it, they couldn't do any problem solving.
Right.
And this is another big part of what I see in the contract intelligence space is that I look at it like a concentric circle or kind of like a donut. The middle is the legal operations folks, the experts, the lawyers who are working to confirm that the contracts are well written and consistently written,
right,
as risk free as they can or as beneficial as they can. And then there's these outer rings of business folk, and those business folk, they're consumers of this data, right? They need that data is input into their processes to improve business performance.
Right.
And right now, that's a problem, is getting that data to these people in a reliable, accurate way.
Right.
And you'd think that's not a new problem. It isn't, but it's still a persistent problem.
Right.
And that's what I'm focused on now. It's, you can talk all about the fanciful parts of neural networks and AI, but really in the end, these people want data pipelined from their contracts into their work streams, and that's what they need.
Yeah, it makes so much sense to me. It's what I saw as sort of the boom of CLM of 2022 had to do with getting at that data, right? We wanted to figure out if we had to worry about force majeure for a pandemic or sanctions for a conflict. And there were companies scrambling to get their hands on that data. And they went, first to CLM to stand up repositories to dig into that data. Now I'm seeing sort of phase 2 of those purchases. We're still trying to refine the data sets, right? And then you layer in what's happened, in the recent months of ChatGPT, in the forefront, and everyone has lost their minds about what does this mean? I actually was having conversations at Clock recently with someone that asked me, does this mean that I have to hire a data scientist to stand up my CLM? And I thought that's a great question, right? It's a great question.
Yes.
Yeah, it's a great question. So I wanted to go ahead.
I was just going to say, it's not surprising to me as I told you, I'm a bit of an outsider into this contracting space. I'm not a lawyer myself. I've written and read plenty of contracts in my day, but I'm not a lawyer. I didn't come into this space knowing that this was the problem to solve. We were solving different technical problems at Cognizer, and folks kept saying, can you do this thing?
Can you do this one?
Yeah, can you? So why are you asking me this question over and over again?
Yes.
And they all had CLMs, and it really made me understand that they were talking about something different. And I was trying to understand it, put my arms around it. But all of what they were saying was, in the end, I need a really reliable way to know what's in my contracts.
Yes.
These are strategically important, and I feel there's a level of opacity not knowing what's inside.
Yeah.
It is interesting, but not surprising that this is a CLM boom in the 2020s.
Yes.
So in my journey through all what's now called digital transformation, I almost said digital transportation. And then we're going there too.
We're going there too.
Yeah. So digital transformation all started with structured data, low-hanging fruit. Like the data was already in a good place. You could easily run machine learning algorithms against it. The technology that we're talking about now is relatively recent, that you could then take an unstructured piece of content, turn it into structured data for this kind of machine learning analysis. Yep. People are still talking, when we talk about this contract intelligence, I still think people are stopping at the wrong place. The place isn't you put the data in the database, the places it's actually, you should be analyzing the data in a graph, because you're actually looking for patterns in this data.
Yeah. And that's what's so fantastic.
That's the big holy grail. Like, that's what people, I think, are still lighting up to. They're talking about GPT and like, oh, okay, that's still part of the how, but not the why. Not the why.
I want to dig into the AI full picture here in just a second, but you made me think of something that I wanted to speak to. So I've been in the CLM space for over 20 years, and it used to be, right? It used to be when I first started in CLM that all we really were looking at is how can we generate an agreement and send it out for e-signature. It was that part of the workflow that everybody was so focused on. And I've seen organizations and CLM vendors and the technology mature in that 20 years, more so than ever in the last 2 years, to say, okay, we can drop that part's easy. How do we get the data out? And most of the CLM tools that I've worked with, prior to this last 2 years, didn't have a fabulous answer for getting the data out. You could import it into a BI tool, you could slice it and dice it that way, but that still didn't allow you to make predictions or proactive decisions about the data in your contracts. And so why I get so excited about the AI abilities now is for the exact reason you said, and it's because now we have the capacity to look at that data from all angles in an automated way and surface decisions to make our contracting proactive. And when I see folks that are nervous about AI or hesitant, or they don't want to employ ChatGPT, or they think ChatGPT is all that AI is, I really want to take an opportunity to educate them to say, AI's always been there in certain formats and structures. And now we're just talking about taking it to the next level.
Yeah.
Dear consumer, you may have seen ChatGPT, but that's not all it is. So
yes, it's interesting. Yes, it's an interesting thread. Machine learning and AI have been around for a long time, and we consume it. But I would say that until the generative part of AI became more commonplace and in people's consciousness, they weren't aware of the fact that they were consuming it. It was simply organic to their experience, and they didn't notice what it was. But I'll give you a few examples of what it is.
Yes.
So anybody who's used Netflix gets a recommendation: complex math using neural networks. How did that? That's in a graph database, right? Like that's how you do it. If you've ever poked around Facebook or TikTok and you see recommendations, same thing, same technology, different goal, right? And even those funny filters on Instagram, all same things, same kind of tech, suggested grammatical changes or spell checking,
predictive text,
predictive type ahead text in the search bar. This is all the kind of AI that's been around for a fair amount of time.
Right.
But that AI was constrained by architecture and technology.
Right.
So hold on, something just weirdly happened to my screen. It just did something. Oh, I'm supposed to close this.
Oh, that's fine. I still see you. You're still good. No worries.
Okay. I just need to find where I am in this display. Okay. Hold on a second.
No worries.
There we are. Sorry. Edit
It's okay.
that out. So, there wasn't enough computational power in the traditional kind of computer chip to do the kind of mathematics that's required for the type of AI that we're using today.
Right.
And funny enough, it wasn't even invented. That technology was invented for video games. And the graphical processing unit was designed for video games.
Right.
And for rich visual experiences. But some very clever people realized, I can work this thing to do complicated math, because actually rendering pixels is complicated.
It's complicated math.
Yeah, so it's very similar to the same kind of complicated math patterns. And then some folks came up with some open source technology that lets you run that math against that chip, and boom, everything changed.
Right.
So now people are startled, and I think that's the right word. And in the
That is
legal
the right
space,
word.
I was just
Yeah.
at Clock, maybe alarmed that there is this new capability, and that the advent of that capability is disruptive for them.
Yes. Yes.
And I actually think that there's both a kernel of truth and a big giant portion of panic that in there, because
Oh,
I don't see it that way. I don't
right.
see it that way. Yeah.
And so I'm interested to find out how do you see it with your background?
Well, my grandpa was a plumber,
Mm-hmm.
and he made things and built things, and there was only one way to do that, and that was by hand.
Mm-hmm.
And there was no concept of manufactured things of that time.
Right.
But now it's way easier to do plumbing. It's just way easier, and nobody hates that.
Right.
Nobody hates that.
Yeah.
My car is a whole lot smarter. It drives a whole lot better. Nobody hates that,
Right.
right? And there's all kinds of conveniences that we look at all the time, and they help us. I wrote my undergraduate thesis on a computer that by today's standard would be considered a toy.
Mm-hmm.
And the fact that the computer can do so much today to help me, and how much other people's work to deliver my work product, to edit my work product, to package it up, those jobs are not around anymore. Nobody's doing that anymore. They're
Right.
doing higher order, higher value things. Nobody hates that.
Right.
Nobody hates that at all. So
Cool.
I do think that there is this part of the AI world now, because of the generative part, that
Mm-hmm.
says, hey, this AI can write my own contracts. So now what am I going to be doing?
Right.
Here's the interesting thing. And I was going to ask you some questions. I know this is a conversation. So
Mm-hmm.
let me ask you to tell me from your point of view as an expert. If you think about all of the contracting work done in a year by lawyers, and the cost of that work, and compare that to the commercial value of the contracts that they generate, what would you say is the ratio economically?
Oh my gosh, it's a fantastic question. I would say we spend a lot more on the repetitive redlining, emailing, discussions about the contract, redrafting it than the value of the contract by far. I don't know what the measurement is, but I would say that work is much more expensive than the actual value of the contracts we're negotiating.
In a lot of cases, the amount of money spent on producing a contract exceeds the value of the contract.
Yeah, I think
And
that's accurate.
yes, so and how an AI might be able to invert that ratio, right? Make it
Yes.
better. And then
Yeah.
you think about the value of the commercial activity, just say in the US, several trillions of dollars of GDP, most of which is somewhere in a contract somewhere.
Right.
And then if you compare that to the total spending on attorneys inside and outside of a corporation and a firm, it's a small fraction of that total. It's not that
Yes.
it's not infinitesimally small, but it's a small fraction. So that means that the contracts themselves are enormously valuable, obviously, in the sense of
Yes.
what they represent in terms of relationships. And there should be some way of capturing that. And the
Right.
more that we can capture, the better it off. So generally, I feel like people shouldn't be hating this idea that there's a power tool. People love power tools. I hate
Right.
doing dishes by hand. I love my dishwasher. No, nobody
Yes.
hates a dishwasher. So
Right.
why hate the AI? And I think the answer is because people don't understand what it's doing.
Right.
Yeah,
That's what I was going to ask you, Randy. So from a because this was the title of this episode is it's not magic,
it's
it's math, right?
it's math, not
And
magic.
so,
That's right.
right?
We like that
So,
phrase in my company. Yes, yes.
yes. So what then, if we're talking about generative AI in these kinds of scenarios, what is the actual math doing? What is the function to get us to help generate contracts or to sort of, so what is the layman's explanation for what's happening in the background?
That's a very good question. So first, to understand that there is a technology called a transformer.
Mm-hmm.
And the underlying part of a generative AI is a transformer. So what we are talking about when people say large language model, the model is a transformer architecture.
Okay.
Okay, so how do they work, right? So there
Mm-hmm.
are two parts of the transformer architecture. There is the decoder part and the encoder part. And so the encoder part is taking the source content and turning parts of it into a mathematical representation. Why? Because it's math and not magic, and
Right.
that's what you have to do to make the neural networks work. And then and so the idea there is you can represent something in reality like text or a picture or a sound in mathematical terms. Why? Well, one way is to find things that are similar, and another way is to create something from them.
Right.
Right.
Right. So you're looking for
So
patterns to surface and make decision, or you're
that's
looking for
right.
the latter. Right.
That's right. So when we said, oh, hey, pixel, to generate an image on a screen requires complex math. Yeah, because
Mm-hmm.
to pixelate the whole screen is complicated. Same thing. That's what, in effect, generative AI is doing with images. So how does it create an image? So it's taking the encoded materials, knows how to create from those some rendering. And what is it
Mm-hmm.
doing is it's asking you for some kind of prompt, right? Which is, tell me what type of picture you're looking for. And using
Right.
the encodings, it goes, oh, I know what those look like. And it can whip one up. It may whip one
Right.
up that looks great or horrible. That it might make
Right. I've
something
seen
up, but
both.
it's gonna whip one up. And
Yeah.
it's using this vectorization to figure out when you give it the prompt, what are you talking about?
Mm-hmm.
And then it understands contextually, and that's an important word, contextually, what you're trying to do, and it can generate that. So that's what the generative part. So if you take sound, another
Mm-hmm.
kind of media, same thing. It can make music or make sounds. So now text is a third type of media, and it can write text, but
Right.
it's all mimicry, right? It didn't create the original work of art that it used to learn and vectorize this content. People
Right.
did that, right?
Right. Mm-hmm.
So it is mimicking what people do with this very complex neural network to, in effect, predict how much it is what the person was asking for in the first place. So it's trying to understand
Right.
what the person asked for in the form of the prompt, trying to interpret that in the form of these vectors, and then trying to render it in a picture, in a sound, or in text. Now, that's kind of what the generative part does.
Mm-hmm.
The encoder part is really, really good, and that's the more transparent part that is very useful to find things, extract them, and put them
Mm-hmm.
in a proper structure in a database. There's a lot of you can use the generative part, the decoder part, to do some of that, but it's more
Yes.
kludgy. There are some models that use both the encoder and decoder together, like T5.
Right.
There are models like GPT that only use the decoder part. There are models like BERT that only use the encoder part. And
Right.
why is all this important is in my grandpa's toolbox, he had different kind of tools. Why? Because you don't use one tool for all jobs. You actually need
Right.
a lot of different tools for certain jobs. And these are all different tools, and that's what they are. And they're not all one size fits all. He didn't just use a wrench. He used
Right.
lots of things, yeah,
Right.
to do his work,
Right.
right?
And so the idea, if you're using two tools, I'm just kind of trying to play this out in a practical application, would be you could use to take data, find the data, and then to generate it into something else, which could be find the data, maybe for a contract, for example, and then we could use that data to then generate an amendment, for example, putting it into context.
Right. You could say, here are 5 samples of my non-disclosure agreement. Now you write me a non-disclosure agreement that's consistent with those. That's the generative part. You could also, we use the generative part of my company for articulation. That's another way of using the generative part, because our philosophy is that the whole purpose of doing this is to get that outer ring of people, those teams, well informed with this contract data. Otherwise, mission not accomplished. And they think in natural language, right? It's the most scalable user experience that we can build is natural. So it's natural sight, natural hearing, natural language, right? So we talked about visuals, audio, text. And you can we use those types of decoder language models to interact with people who are asking questions about the contracts. And that's one of the facets of our product. So we're using both the encoder and the decoder. Our architecture, like Watson's architecture, circling back, is based on pipelines. And this, I think, is a smart move. I told you that the legal department and several others were on the latter part of this wave of digital transformation because it was unstructured data that it was being asked to apply, right? So structured data easy, unstructured data gnarly, and the reality is that you want to make that data as easily consumed and readily available as possible, and letting people talk to their data is really a cool way of doing that. So that's a very cool way of using generative AI. And again, no, I don't think the legal ops department wants the endless queue of folks asking for the details in the contract. That's not productive. That's not moving the needle for the whole corporation. It's really a pedestrian activity of fetch this data and give it to me. AI is a really great assistant to do that. And it uses both the encoder and the decoder to do that.
How I see that sort of translating into like an everyday activity for a legal ops person is, I think of it like, last year, if I wanted to search my repository of contract data, I would go in and enter search terms, kind of like I do when I'm looking for a transaction in my checking account. And I don't know if it was in August, maybe, I can't quite remember. I thought it might have been this store, but I'm not certain. And it maybe was around this amount. And so I'm fudging the numbers around. I'm just trying to get the data. When you apply AI to large language models or to your contract repository, and you then layer in a technology like ChatGPT, you can have a conversation with your repository to say, I think it's in August. I think it's with this customer. Can you return the results of all of these for me in a way that I can understand? And so
you can almost do that. You need to introduce something else. It's called a retriever. Okay, so you can't do that without the retriever. But this is it's not a mystery. People have been using vector databases for this retriever. That's what we do. And so I mentioned vectors, and that's where they're stored. And so the model on its own has no memory without the retriever. So you can think of it, can you imagine a very, 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 very smart person can't remember what you asked. So you ask, like, okay, I answered the question, but if you ask it again, I have to answer it again. Yeah, you can't take my answer, store it, and give it back to you. That's what the retriever does, right? And
Yeah.
you really want to think about these issues in that context, which is it's not just one technology; it's a bunch.
It's a bunch, right?
It's a bunch. It's a bunch of different things. It is not a one size fits all. It's a whole family of technologies. And I talked to one company just recently, and the problem that they were having sounds easy to solve. Turns out not easy to solve. Is hey, I have a hard time getting all the data in these tables and charts in my contracts organized in a way that I can use them. Like, really?
Yes.
That's that, but
Doesn't
that's
that sound simple? But it's so difficult, as well as like trying to draft a contract and populate tables has
yeah.
always been it's very difficult for most tools to handle. So anyway, curious about.
It's a great example because sometimes you'll notice that as a human we can see, oh, that's a table or that's a
Mm-hmm.
chart, but there's no
Right.
lines around it. But we can
But we
impute
know, yeah.
we can see
Yeah.
the order because we're using our eyes to do that, right?
Right.
And so
Mm-hmm.
that's an example of a combination of technologies. You might need a transformer to power an image recognizer that says, that's a table, right? It doesn't have lines on it, but it's still a table. And then you use another thing to pull the data out of the table and
Right.
yet another thing to organize it. And so that's a combination of technologies. You can't just throw the table at ChatGPT.
Right.
It doesn't
Right.
work like that. So
So the
having it organized
combination
is important. Yeah.
and the combination of technologies is indeed the neural network, correct? Because you're taking the combination. Is that my understanding right?
Almost. So a retriever, for example, is not in the neural network. It is something
Okay.
that is ancillary to it. You can think of it as the data store for the output of the transformer. So in the encoder part,
Okay, that makes sense.
you're giving the transformer. So okay, back up a second. The transformer knows nothing, and then you train it, right?
Mm-hmm.
How do you
Right.
train it? Well, in the classic sense, it's a multi-step process. And the first step is what's called unsupervised, which means just let it read or let it look at videos or let it look at pictures or let it listen to sound, right? You're not telling it
With
anything.
no other instruction,
That's one
just
of the nice
listen.
things
Yeah, or
about
watch.
neural networks. You don't tell it the right answer. It tells you the right answer,
Right.
right? But you
Mm-hmm.
have to give it some context. And then it can, as it's training, it's adjusting what is inside the network called weights, model weights. And
Mm-hmm.
those model weights are used in a series of steps to get ever more accurate output predictions.
Yes.
So the
Yes.
question is, what's the output? The output of the encoder is a vector. What's a vector? It's a numeric representation of something, like let's say
Yes.
a sentence. Now, these large language models use this, and their vectors are huge, right? Because
Mm-hmm.
they're a large language model. That's why they're called large,
Yes.
because there's lots of parameters, and they make these giant vectors. And vectors
Mm-hmm.
are numbers, and numbers require storage, so you need some place to store this stuff. So not everything is inside the neural network.
Okay.
Some things are produced by the neural network, and you need a place to store it.
Let's just store
Right.
them. Right.
Yeah. You can
Okay.
think of it as like an index.
Yep. No, I totally understand. And then, currently, I have a lot of conversations with customers about ingestion of data. That's sort of where most people get introduced to AI in the CLM space. Is that we're taking a tool, which is, we're letting it read the contracts or look at the contracts. So this activity that you're talking about, we talk to our customers on a much more less technical description. We have to train the tool. You'll hear that a lot in implementations. And so what we mean by that is we're letting the neural network, sort of the tool, loose on the contract data in order to surface the insights. Is that a correct statement?
Almost. So there's
Okay.
the supervised learning part. So there's
Mm-hmm.
an unsupervised. You're just letting it read or see or
Right.
listen. The supervised is that you're now providing it with some context.
There we go.
So
Mm-hmm.
you have to, and that's done through labeling.
Mm-hmm.
So that you could think of labeling as saying, in the context of a contract, oh, here's the start of an indemnification clause. Here's the ending
Yes.
of it, right? So that it knows, oh, when I have seen this, I vectorized it. Now let me go look for other vectors that are like this. Now I can recognize that. And it's doing that through a math algorithm.
Mm-hmm.
And that's what's important, right? Is to be able to
Yes.
find that pattern. So there is a part of this technology that, of course, is just able to absorb like a baby does. You don't, you tell a baby, this is a banana and this is an apple. But for the most part, babies are just absorbing the world and learning.
Right. Mm-hmm.
And then you can give them annotated language lessons, and they can learn a
Yes.
language, and then they can
Mm-hmm.
create and generate for you something. And
I
this is
love that
very,
example.
very similar, very, very similar.
Yeah.
And so that's a good paradigm is
Mm-hmm.
first absorb, second instruct, right?
Mm-hmm.
Third
Yes.
interpret or create. And so that's the
Right.
continuum. In plain old English, it's
Yeah.
obviously a lot more complex in
Yes.
data science terms and math
Yeah.
terms, but in plain old English, that's what's going on.
And I think
So
what's been happening is the absorb, right? Is the absorb.
that's
We've
right.
been in that phase for a while. And
Right.
then I think now we're positioned to move into the create. And that's what I think some people, there's concern around, like, what does that look like? Or what does that mean? Or does that take my job? Or how does that impact me? Because I've been the person that creates. But I don't think that we get the human out of the loop. We just create better things faster.
Yeah. So there's a lot of drudgery. I have a family friend who's just graduated UC Law School in San
Mm-hmm.
Francisco. He's got a good career ahead of him. And I would say that if he were graduating 15 years ago, 20 years ago, he was looking at 80, 90-hour weeks of some serious drudgery
Yeah.
that a senior lawyer needed done to facilitate that work, right?
Mm-hmm.
And so you could think of the whole output of the law firm as being limited by that drudgery. So
Right.
I would say that it's about capacity. There's way more lawyering than can be lawyered right now because there's more
Yes.
demand for lawyers than there are supply of lawyers.
Right.
So I do not look at this as a bad thing. There's
Yeah.
way more higher value work for this young man to do
Mm-hmm.
with his intellect than this drudgery. And the drudgery is hunting and finding
Yes.
specific things, right?
Right.
It's
Yeah.
hunting and finding, right? It's
Yeah.
not
Hunting and
strategic.
finding.
It's not
Right.
strategic.
So we are saying let's let the technology do the hunting and finding so that we
Or wash
can.
your dishes or whatever you like,
Right.
right?
Yes. Wash your dishes. I'm a fan of that. Yeah. All the things, right? Drive your
All the
car,
things.
do
That's
the
right.
things.
All the things.
Yes.
And I don't look at this as a negative thing, but I do think that what one needs to think about is the after. Like, okay, there was the before, and that's how you might have been trained. Now there's the after. Embrace that after so
Yeah.
that you can accelerate your own life's journey and your own work journey and your own value proposition, even your own unique selling proposition as a
Yeah.
professional. Yeah.
I agree. And so I think you and I are of similar mind that um, generative AI and AI are not going away. They will be additive, and hiding from it or not leaning into learning about it is probably not the best advice. I would say that it's not going away. Your thought?
Nobody is upset about text and nobody's upset about email. That displaced a
Right.
whole nother paradigm of delivering information. Nobody
Yes.
really liked their fax machine. Nobody wanted to stand in front of it. Nobody wanted to be late at night in front of the stupid printer binding up a book to give to
Yes. All those
a
things I've
courier.
done.
Nobody liked those things. Nobody liked them. They just don't
Right.
remember that they didn't like them, but they did not like them, and they were happy when
Yeah.
it was no longer their job to do it.
Yeah, I
And
agree.
Yeah. And so when Adobe came out with PDF, and it sounds simple, also very complex math, to make a PDF, and people thought, oh, great. Nobody was worried about job displacement, right? I
Right.
think this is a convenience. I look at this as a power tool. But
Yeah.
I do think that there needs to be some guardrails on it. And I'd like to at least bring up a couple points there.
Yes. Yeah, I would love to talk about that part of it really quickly before we move to that. I just wanted to give one more illustrative example to your point, and that is, my job was not displaced because I no longer had to make copies or send out FedEx for a contract because e-signature came into the forefront when I was a paralegal. It just meant I could send more contracts faster and the business could turn things on faster for our customers. So I used that example of technology coming into my life, 20 something years ago, and it didn't displace me. It just made me more efficient. So I look at this in sort of the same vein. I just wanted to throw that out there because I see it so many ways as like you see the banker's boxes full of contracts and that no longer exists anymore. So we forget. And I just wanted to illustrate that piece of it as well. So I'm very interested in talking about guardrails for AI. I would love to hear your thoughts on. I know there's a lot of discussion about that sort of around, the universe. So,
Well,
tell me what you think.
I've made some friends in the space, and they're smart people, and I listen to them.
Mm-hmm.
When I talk to them about commercializing some of this AI, which of course I'm in the business of doing, and it's worth noting that I answer these questions a lot. This comes up
Sure.
a lot, and
Yeah.
and one of the things that comes up a lot is with regard to data security and privacy,
Mm-hmm.
which is very much important. If you think about the big picture of what we were talking about, contracts are strategic assets. They're privileged information. You have to impose rules on entitlements to access that information in an
Right.
organization, data governance, things of this nature,
Mm-hmm.
and you need to comply with rules for security and privacy and regulation, all manner of regulation, right? So there are AI that are explainable. It's a very important thing to understand. I would only use explainable AI. It better tell me
Mm-hmm.
where it got its answer from. Otherwise, I can't trust that answer.
Right. The
But
transparency.
the other part about generative AI is that it can generate anything from its original source content that it was fed, including things you don't want it to articulate or generate. You have to be circumspect about what you feed it and how you
Mm-hmm.
feed it, right? And if you're, for example, curious about protecting PII or PHI data, you have to be very careful about what you give an AI model and what you ask of it. And there are ways to correct for that, and there are techniques
Mm-hmm.
to use. So it's a solvable problem. I hear a lot that people are of two minds. Quite honestly, I would call about using open AI, which is out on the internet. It's not
Mm-hmm.
inside your control, and it's worth
Right.
noting that the there's two ways of looking at it, both of which were articulated at the last clock session by two different people. One said, it's like spell check. Nobody has a problem with spell check reading their contracts. So why would they have a problem with this giant AI reading their contract? I'm like, okay, I get the point.
Mm-hmm.
It's thematically consistent, but not technically consistent. Those are two different things.
Two different
And
things.
two different
Yeah.
things. Yeah.
Two different equations.
Two different things. Yeah. And then there's the flip side, which is, yeah, there's no way I'm analyzing these contracts in a manner that exposes them out into the world. I'm not allowed to do that. I'm not allowed.
Yeah.
Yeah. And so I've had discussions where people confirm, hey, are you sending contracts outside of a protected area to analyze them? And our answer is no. But we
Mm-hmm.
do use, and we can use those technologies to solve problems because we built open pipelines to do that. So technically the answer is yes. If there are two customers and one said, I belong to the spell check philosophy, it's easy to enable. And I think this is important because There's a continuum of use cases. It's not all one use case, some of which are good for language models that are inside of a cloud. And there are some that
Yep.
you can use. We use those. And there are some that are outside the cloud because they're simply too large to put inside your cloud, or that you don't get a chance to do that. That's one thing to know. The other thing to know is that with the largest of these language models, and GPT is not by even any metric the largest. There's very large ones that are frightening in their size for, from an architectural point of view. It's just remarkable. You have to think about, well, what does it take to move the needle in terms of its ability to understand contract or legal language? So a lot of these large language models were trained on a giant corpus of publicly available information. And some of that corpus might have been filings from the SEC or filings from other similar agencies in different countries, all of which is public information, a lot of which is legal language contracts, things like that. But as a percentage of the total unsupervised learning that it did, it's tiny, right? So, you're not going to move the needle. You're not adjusting those weights. Those weights are already, that model's printed. You're not adjusting those weights. They train that, and you go from 3.5 to 4, 4.5, or whatever. You're using these things don't change those weights. So what it means is that the more domain specific your application, the more beneficial it will be to train up your own language models from generic ones that have been taught to learn English and French and Spanish and things like that by reading public stuff. And then you teach them what you want them to know. And so there's another way of controlling for the guardrails. There's two ways. One is how you control the inputs, and the other is which models do you use for which functions, right? And they're not all one size.
That's so fascinating to me. When you're looking at the future of AI, and I know that could be tomorrow. It moves so quickly. So what are you where are you seeing some areas that can be beneficially impacted in sort of the contracting space, which I know is not your home. You don't live in the contracting space per se. You live in, I'm a
guest. I'm a guest
You're
into the contract. Yeah. a respectful guest. I realize that even though we're very good technologists, we need to marry our technology with domain expertise like yours. And the firm that you work for and other firms, these are firms that can do a really good job of articulating the sought after goal and some of the methodologies that they think are worth trying to follow. So I would say that another area of transformer based neural networks that we are using, and I mentioned, is on the end side, past the transformer, past the retriever, and into the graph. So graph databases, which are part of our architecture, we think are elemental to analyzing contracts, because contracts are relationships, and tabular structures don't reflect relationships really well. They have some boundaries in terms of relationships, and they can become unwieldy if you try to create a gazillion cross-reference tables in order to preserve those relationships. And graphs were created organically to solve that problem, and they're asymmetric, which means you don't have to have the same a number of attributes for every node in the network in order to describe it, and you can change those attributes. Very cool stuff.
It's very cool. As I'm listening to you, I'm thinking of my days of trying to map parent-child relationships in an Excel spreadsheet.
Yeah. So you bring this up. Let's take that. Contract families, parent-child relationships. Gnarly problem. Why?
Yes.
Because people didn't do their bookkeeping. They weren't clean. And then they got the big junk drawer of contracts, right? And all they did was just digitized everything. It's all PDFs, and they don't know what's inside. Yes. And they don't know the relationships. And let's just say even their contracting systems didn't necessarily solve that problem. I'm being generous here.
Right.
They didn't solve that problem. So a graph neural network, which is what we're doing, right? This is our world, is taking all the data that's been extracted through all of these large language models and structured, and then analyzing that. Why? Well, people don't understand what those contract families are. Graph neural network solves that problem. People are trying to do what Katie would describe as retemplating. Graph neural networks solve that problem. People are trying to understand risk, and they're looking at their contract data and they want to use other data inside the organization, like supply chain data, which we were talking about earlier, and other types of data like financial risk data, economic data, military data, all kinds of data to a certain, and you can put all that in a graph and run graph neural networks. And remember, key thing about a neural network is you don't tell it the answer. It tells you. Right.
Yeah.
So you don't know enough about this. It's brain numbing to try to think about all that data and make sense of it yourself, or poke through a spreadsheet and do this manually. It's either brain melting in terms of that level of tedium, or brain numbing just because there's too many numbers, and who can do vector algebra with thousands of nobody can do
and
this.
Error, all the thing.
So a graph neural network is a super powerful way. And I think this is the holy grail. This is what I'm passionate about, is really understanding a contractual relationship and contractual relationships holistically. Across
the organization, with the data points that are important to the organization. Yeah.
That's right. It is the next big step of business intelligence. It simply doesn't exist. And you can't get there with an LLM. It doesn't do that. And that's what I'm saying. You need a combination of things to get to the goal, right? And it's like my grandpa, a lot of tools, right? But smart people know how to put those tools together to make something that we need. And I believe that's the next big area of opportunity, is being able to use this contract data like we do cybersecurity data for surveillance, for compliance, for detection, for risk sensing, all kinds of applications.
It's so exciting. I love where we're going with all these tools and technology.
And nobody should hate this, because this is what drives value in an organization. And quite honestly, I work for a company. My job is to create value for that organization. And in exchange, they give me some dollars. It's a good deal.
Sounds like it's not a bad deal.
It's not a bad deal.
I love this conversation. I learned so much from you, Randy, every time we talk. And what I love is that it all comes down to, it's mathematics. It's not magic. It's not making decisions for us. It's programmed data asking the right questions with numbers and pluses and minuses and lots of them.
It's true. Right? I mean, over drinks, we can talk about consciousness and what it all means, and, sentience and all these things. And truly, I think that the takeaway here is that there will be a positive virtue cycle with this, and there will be negative virtue cycles with this. Any technology. I mean, if you ask me, if we have a personal conversation, I would say I think social media has been corrosive for our society. It is a technology that hasn't done a good thing, and AI can do that. And we need to know that. We need to be cogent about our thinking about that. It would be wrong to be naive about it. But when applied properly, it can be really beneficial, and it can really do things that we as people cannot. And I think that's important. I was just having a conversation with a pal earlier today. We were talking about dogs that can sniff out conditions that we have, like cancer, or a sense of there's a diabetic attack about to happen. We can't do that.
Right.
Now, an AI can read a MRI more accurately than our eyes in many cases, because sometimes our eyes get tired, or sometimes it sees something. That's not a bad thing. Nor is it a bad thing that dog can sniff out cancer, because that's really the whole thing. Nobody wants cancer. So start with the end state. Nobody wants cancer.
Nobody wants risk in their contracts.
That's right. Nobody wants to get sued. Nobody wants to have that renewal that cost them $1 million for something that they're not using. Nobody wanted to skip out on an obligation that could really please their customer if you fulfilled it. These are things that people don't want to happen. And right now they're happening all the time.
Yes. And there are ways that we can stop that. Mm-hmm. Yeah. By looking at the data. So
that's right.
Yeah. I'm so excited about this conversation. We could talk for hours about it. Maybe we'll have to do a part two for certain, a certain part two. I've loved our time together, Randy. Thank you so much for joining me. This has been a pleasure.
Thank you. It's been an honor and a privilege, and always fun to talk to you.